All right, so for some reason the thing is numbered from 7 and then it goes to 10, but we won't worry about those numbers. Okay, so we have this researcher who obtains the weights of 20 male patients with lung cancer, and we have all of those 20 weights here. We want to create a dot plot, a stem and leaf diagram, and a histogram for this data. All right, so I'm going to create the stem and leaf, and I'm going to create the histogram, but I'll just talk about the dot plot because it's going to really look just like the histogram with dots instead of with bars. So what I've done is I've gone ahead and transferred this data into Excel. So let's go to Excel, and let me pull this over so you can see the data. And I also want to pull it up here. Okay, so I'm going to start with the stem and leaf, and let's notice that our smallest piece of data here is 120, and the largest is 250. So when we do the stems, we want, since these are 3-digit pieces of data, we want a 2-digit stem, and we want to start with the smallest stem and go all the way up to the largest, and we don't want to skip any numbers. So we're going to go 12, 13, 14, all the way up to 25 for the 150. All right, so there's my stems. Now my leaves are that 3rd digit. So let's just go down through our list and put the leaves here on the right side. So 180, we're going to go to our 18 and put a 0 behind it. 144, we'll go to our 14 and put a 4 behind it. 138, put an 8 behind our 13. We've already got something behind 14, so we need to put a different cell there for that one. 150, 194, 250, 133, 120, 139, 144, 140, 152, 163, 149, 155. Oops. 160, 172, 141, and 121. Okay, now when I get done with these, I always like to go through and count and make sure that I have not skipped any numbers, because that's easy to do when making a stem and leaf diagram. So let's see, all we need to do is count our leaves. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All there. Now be careful, you don't want to leave out these things that do not have numbers representing them. That gap needs to be there so we can see that spread in the data. Now we're not quite done, because with a stem and leaf diagram you always want to leave your leaves in numerical order. So we do need to rearrange these. So 0 and 1 is okay, but this one I need to rearrange the 3 and the 8, so it needs to be 3, 8, 9, and obviously 14 needs to be in order. So let's see, 0, 1, 2, 4, 4, 9. So 0, 1, 2, 4, 4, 9. And then 15, that looks like it's okay. 16, we need to put in order. 0 and 3. And then the rest of it doesn't matter because there's only one piece of data. So we're going to make the histogram now, and it should look a lot like this stem and leaf diagram turned on its side. So we should see that we have bars going up here, here, the highest one at 14, lower one at 15, and so on. And then this gap between just one tiny bar at 25. All right, so let's make our histogram. Now to do that, we need to highlight our data, and then we'll go to the insert function and over to the little histogram picture right there. And I'm going to click on the histogram, and it makes a very poor histogram to begin with because it only gives 4 possible bins, which is way too few. So we have to change that so that it is more reflective of what the data should look like. We need to spread that data out a little bit more. All right, so to do that, let's just click on this over here, and you can't see it, so let me just move this window over so you can. Oops, changed on me there. All right, move it a little bit further. So we want to change our bin width to match more like what we had with our stem leaf diagram. So I'm going to change my bin width to 10. And the number of bins, you notice it automatically adjusted that. And now our histogram looks more like the stem and leaf diagram. Okay, so you'll notice that now that looks a whole lot like the stem and leaf diagram. However, I will note this about this diagram. It tends to put, since we have a 140 for example, to put the 140 both in this bar and in this bar. So what we can do to fix that is make our bin width a decimal so that those numbers that would overlap there won't overlap anymore. So maybe I'll make it 10.1 and adjust it that way. Keep the number of bins at 13. And notice now it becomes more representative of what it should look like rather than putting one piece of data in 2 places. All right, now if we did a dot plot is going to look just like this histogram, the difference being that we won't necessarily have this vertical axis, but we can still have these categories down at the bottom, and instead of having a bar going up to 2 here, we would simply have 2 dots going up, and 4 dots here, and 6 dots here, and so on. So a dot plot will look an awful lot like the histogram, and will serve the same purpose. It's just this is a little bit easier to look at than looking at dots and having to count the number of dots. All right, now let me go to the next one in our review. We are going to find the mean, mode, median, and standard deviation for 5 pieces of data, 12, 34, 18, 48, and 11. Now, since we need to find the median, I'm going to put these in order to begin with. So let's see, 11, 12, 18, 34, 48. Okay, so 11, 12, 18, 34, 48. Now that I've got those in order there, it is clear what the middle of the data is. It's 18. That's my median. So remember, if we have an odd number of data, the middle piece of data is our median. If we have an even number of data, we have to average the 2 middle pieces of data. All right, so we got our median. Our mode, remember, is the thing that occurs the most often here. They're all distinctly different, so there's really no mode. All right, and then let's get our mean. We could, of course, do this one in our calculator quite easily, add these 5 numbers up and divide by 5. But since we're in Excel, let's just do it more quickly. So we'll use equal average. And you notice that I have this in column V. This is cell number 2, so V2 to V6. And my average is 24.6. So that's our mean. Write that beside it. All right, and let's get our standard deviation. Now, it didn't say whether this was sample data or population data, so we're going to assume it's sample data since there's only 5 pieces of data. So we'll use the sample standard deviation. And those two formulas are just a little bit different, so it does make a difference. But the majority of time we can assume that it's sample data. All right, so standard dev.s, and again we're going to tell it V2 to V6, and that standard deviation is 15.99375. All right, so let's look at our next one, and I believe we might be working with the same set of data. We'll see. Determine if Chebyshev's rule and the empirical rule apply to the data above in number 10. Well, we are at least working with number 10, which we have that data in here. So I'm going to move this back over again to our original data for number 10, which is this data here. And to see whether or not Chebyshev's rule and whether or not the empirical rule apply, we need to get the mean and the standard deviation here. So let's go ahead, whoops, highlight all 20 pieces of, oh, well, I'm sorry, we don't need to highlight. We're going to go equal average. And this is in column A. And we're going to to row 20. And our average is 154.35. And now let's do the same thing to get the standard deviation. Equal standdev.s V, I'm sorry, V. It was V a minute ago, but now we're in column A, A1 to A20. And there's my standard deviation. All right, let's start with our empirical rule. Our empirical rule says that approximately 68% of the data will fall between one standard deviation of the mean. So let's find out what one standard deviation from the mean is. All right, so 154.35 is our mean, and if we add and subtract our standard deviation, and I'm just going to take it out 4 decimal places, there's the bottom one standard deviation away below the mean. Let's get one standard deviation above the mean. Whoops, I forgot my equal sign, which I have a tendency to do sometimes. All right, so 125.46 and 183.235. All right, so that's one standard deviation above and below the mean. Let's count how many pieces of data fall between 125.465 and 183.235. Let's see, there's 1, 2, 3, 4, 5, that one doesn't, 6, that one doesn't, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 of our 20 pieces of data. Now that is 85%, 0.85, which is not approximately 68%. Okay, so if, when we're dealing with the empirical rule, that approximately means it should be pretty close to 68%. In this case, 85% is not close to 68%. If we had 67%, 69%, we might be able to say it's approximately 68%, but 85% is not. All right, so it's very important to remember the word approximately in the empirical rule. It needs to be approximately, whereas Chebyshev's says at least. Okay, so this does not fit our empirical rule, so doesn't satisfy empirical rule. And you might also notice that our histogram over here was definitely not a normal shaped, bell-shaped curve, which we have to have for the empirical rule. We have something that is kind of